Okay, can you guys hear me? Okay, welcome guys. Welcome to our third session of XMUM Tech Lab Expert session. So this is our third session for this month. Okay, so it's very exciting to have you guys here today, and also it's very exciting that today we invited a speaker to discuss about introduction to AWS Cloud. So first, let me tell you guys, for you guys, probably you are new here. So we are from XMUM Tech Lab, Xiamen University Malaysia Tech Lab. We have this event called X-Pert, which is we invite popular speakers from different technology industry to share their experience and share their knowledge to university students. Okay. Probably without further ado, Faz, are you there? Hello? Is it probably... Hello? Okay, probably... Okay.
Can you hear me now?
Yeah, I can hear you now. Yeah.
Awesome. Okay. All right.
Yeah, sure.
Awesome.
Hi, Faz.
Cool. Yeah. Hey, Kimsey. Thanks for joining.
Yeah, sure.
Please having me over here.
Yeah.
For the section on a Friday evening.
Yeah. Probably could you probably introduce a little bit about yourself to our audience, talk about what you do, and yeah.
Yeah, totally. I mean, so hey everyone, I'm Faz. I work at a cloud provider called Amazon Web Services out of Malaysia, and I've been in Malaysia for over 5 years. I've been in this industry for over 16 years. Started as a developer in Java. So if anyone is still learning Java, yeah, I've done it like many years ago. So I still have some knacks here and there. So if you're ever interested, you can reach out to me. Throughout the years, I've worked through different companies, different countries. Before landing in Malaysia, I was in the Middle East for some time, and I joined AWS like 2 years ago, and I've been working with customers in Malaysia and abroad on how to get them to the cloud and what it is. And even today's session, in fact, is kind of like it's a discussion which I usually have with customers or people who are new to the cloud, whether you're someone who's already running a business or whether you're someone who's in uni, right? You will see that a lot of the concepts today I'm going to be covering are very basic, because the idea with the cloud is that you need to first understand the fundamentals, go with the first principles, and then move on forward. So it makes it much more easier to understand what you're getting out of the cloud. So yeah.
Yeah, we are very happy to have Faz here, because I actually joined one of your session previously. So then after that session, I feel like, definitely we need to invite you here to let students to have a wider eyes, wider knowledge about cloud, especially like cloud DevOps, all these kinds of things. Yeah. I think probably let's start now. Let's start now. Yeah.
Sure.
This is the stage for you.
Screen. Yep.
Yeah, sure. This is the stage for you.
Let me just get this. So I'm going to take over the screen share.
Yeah, sure. Yeah.
And this shows me all the apps. Sorry, sometimes Zoom is something which I don't use. So I'm just figuring out how do I get to sharing the whole screen versus just a window.
Okay.
Oh, that's interesting. It doesn't show it. Okay, fine. Fair enough. You know what? I'll skip it again. Cool. Yeah. Just let me know once you can see the screen. I think you all should be able to. All right.
I can see your screen now. Yeah.
Awesome.
Yeah. After you.
Okay. Just give me a sec. I'm just moving Zoom around because I want to get the chat box for something useful later. All right. Cool. All right. So yeah, thanks for coming in today for the session. So I'm Faz, like I mentioned earlier. Since I've given my intro already, I think we can skip all of this. So I'm 16 years in the industry, been doing all of this. One question I usually get as part of my job is, what exactly do I do? This is basically what happens. So we have three perspectives in this. What customers usually think I do is that I talk a lot of tech. I draw with colorful markers. I'll have markers with me around, and then wherever there's a whiteboard, I start drawing arrows and boxes, and then showing to people, okay, hey, you know what? This is how you can do stuff on the AWS cloud. What the company thinks, what AWS thinks I do, is that I have goals, right? And I have certain things which I have to do in terms of engagements, and that I'm always talking about AWS products. And I'm trying to help people and influence them on how to choose AWS. But what I think I do, if you ask me, is that I'm actually helping to foster the ecosystems in ASEAN and in Malaysia. I'm helping to work with customers and work with people who are trying to get into tech in general, and then try to understand, okay, you know what, I have this cloud, I think I have an awesome idea. How do I translate that into something that's workable? And that's what drives me. That's what I'm passionate about in all of this. And one of the things I really love in Malaysia, like you mentioned right now that you've met me in a community talk, and I'm passionate about communities in Malaysia, right? I'm passionate about attending meetups and talking to people, seeing what they are learning right now, or what are they going to learn next, and how I can help over there. So that's a very good segue for a call out I'm having right now. This is something you can reach out to me later on also. So I'm calling for community speakers, and community speakers in general are folks who are already talking in community events, right? Maybe an event like this for a tech club in the uni or maybe outside somewhere, and you're looking for help in content, you're looking for help for samples, maybe you have some code, you're not sure, okay, what kind of sample I can show, and maybe in general, just speaking guidance and mentoring. So AWS has a program called the AWS Devex Mentor, and as part of that program, you get buddied up with a solutions architect like me, who helps you to make impactful content. Because here's the thing, right? When you actually go out into the community and you start talking to people, you want to make sure your message reaches across, like, clearly, and you're always having a call to action, and so that people get excited, and then they actually go and then go and build something on the cloud, right? And that's basically what you want to do. So we are here to help. And if you're interested, sign up to know more. Here's the QR code for this, and I'll also paste the link in the chat box, which was just here. I think it disappeared again. Wait. Where did it go? Right. Right. Yeah. So that's the link. You can just go in over there and then have a look. Cool. So with that, let's get started with today's agenda. One of the things I mentioned was that we're going to start with the basics, right? So just to get a show of hands, how many of you over here are already, like developers, programmers? You're already like building maybe websites or writing code. If you could just put a +1 in the chat box, just for me to, gauge how many of you are doing that already. All right. Okay, that's good. So we have 22 participants, and only 3 people are programmers. Okay, no worries. So this is good, because what I usually do when it's a cloud 101 session is I always go back to the basics. I try to, like, go back to what are the fundamentals, first principles, if you want to see it better. And the idea is that when you get your head around some of these concepts, then it makes it easier to understand what the cloud brings for you, right? And what I'm going to do is, we have time for Q&A towards the end. We're going to keep this focused on the concepts, and if there is still some time, I'm going to do a demo. If not, then we can always go to the questions and then do a demo at that time also. So let's quickly get started. One of the things which I want to go back to and start from the beginning is basically this whole concept of a server, right? Of a computer, which is something which people use. And they usually talk about it. If you're trying to host something, trying to host a website, people say, okay, you need a server, right? So what does a server actually have, right? And primarily when you go to, whoops, wait, just give me a sec. Oh, it's gone to the end, my bad.
It's okay.
Right, yeah. It happens in Zoom. It's like the windows are all over the place. I'm trying to figure out where it is. No worries. Right. So a server is no different than a computer. So when you compare it, it has similar things like to a normal desktop or a laptop, which you're having in your uni or maybe at home. And it's composed of what you call as a CPU, a computing processor, memory, and also a disk. Right. So this is basically how you're doing it. But when you start looking at what a server actually brings to the table, it becomes different, because the components are similar and they are similar to other things which you see, right? If you take a mobile phone, it has something similar. It has a disk, it has storage, and then afterwards it has also a CPU of a processor of sorts, and then a desktop or a laptop or this. But with the server, it changes a bit, because the expectation you're having with the server is that it's something that will always keep running, right? It's 24/7, always keeps running without any failure. And even if it fails, it's supposed to recover from failure very well, so that your stuff continues to work. also beyond that, you expect the server to do a lot of things. You expect it to handle any kind of request that is sent to it, right? So you can handle a simple data request, or you want that server to also handle machine learning processing, right? And we'll get to a bit of that as part of the demo towards the end. And it's interesting to understand, right, how things have changed over the years, how the expectations have changed from what a computer can actually do and what more it can bring to the table. But to understand that whole nuance of what a computer does, we need to step back to the very basics of a computer. And if some of you are thinking, okay, this is too basic, apologies on that, but I think it makes sense to have a baseline for everyone in this case. So let's all be inclusive in this. So let's get started with the very basic thing, right? The simple math problem, right? So you have you're doing a simple math program, and you look at 1 + 2, right? As kids, we have learned addition so well that when we just look at it, we immediately come up with the answer. But there are a couple of steps you use to arrive to that answer, right? Even though you're doing it just without thinking. And what you'll see is that the process is simple, right? So there is an input that is coming in, right? So you see that there are 2 numbers that are coming in, and then you receive one part of the input, and then you receive another part of the input. And then what you do is you're kind of like storing it somewhere, right? Maybe in your head somewhere, you're noting it down, or maybe you're writing it down somewhere. And then you say, okay, fine, I'm going to do an operation on this. So you do an addition, right? So you add both of them, and then you get a result, which is 3. And immediately you say, hey, you know what, I got a result, and you write it back on this board, which you have. So that's an output, right? And that's basically what you do with a very simple equation. And with a computer, it's doing the same thing. It's doing the same process. And to do that process, we have a couple of components built in which allow you to actually go towards that, right? So, so let's say you have the same problem. How would a CPU actually solve this? So first, the CPU gets an input, right? So it gets an operation, and then it gets 2 numbers as part of this. People who are learning compilers, for example, will understand this format where you're actually saying you first send the operation and then you send the operands across. So that's where it comes from. The next step is that the CPU actually has to remember the input, so it has to store it somewhere. So it stores it in something known as registers. And after that, the operation is sent, along with the operation, and the address to the register is sent to the ELU. It does the processing and then sends it back, and it stores it in a register, and then you get it back, and then that's the output. So that output which you have is now coming from the ELU, but the CPU is not smart enough to remember this, right? So that's why you have to always use a register always in this case. So the CPU is done, program is executed, a line is executed, and so now it's done, right? So the computer works from a processor perspective. And if you notice in this case, when you have more equations or you have more things to process, you'll notice that everything goes line by line, right? So the CPU reads everything line by line. It's measured in a metric called clock, hertz, and then that's the speed of the processor. Now, if you want to scale this out, like if we want to scale our brain, what do we do, right? We have things available on the market. You can eat and drink. Maybe you can actually sharpen your skills by actually doing more exercises and things like that. In a CPU, it's pretty straightforward. You add more cores to it so that it can run more processing in parallel. One of the things to understand is a limitation for a core is that it's always limited at 4 gigahertz. That's the max clock speed you can go at, which is why then what you do is you start adding more cores. So you get dual core, triple core, quad core. I am from a time when I started using CPUs. I was at the 286 time, and then afterwards I got Pentium only, like I believe it was just before 2000, right? So I'm that old. Now it's like everyone has quad cores and 8 cores and 12 cores in their laptops and even on their phones. If anyone's using any of the gaming phones recently, so this is basically how you do the processing part. Now, another thing which you get in the processor is the cache, right? And a cache is basically, think of it as a place to have data storage, much more than a register, where you can store data closer to the CPU. Because one of the things to understand is that in any kind of process where you have to fetch data and process it, you have latency in place, right? So the closer any storage is to the point where processing is being done, the faster your processing becomes, because fetching the data, putting it back again, and then maybe doing more computation on it becomes faster because of that. This is similar to another concept in the cloud or anything which you've seen recently. People who are into website development would notice that you could do something similar with something known as content delivery networks, right? CDNs. You have photos, you have images, you have videos, and then you cache that somewhere so that anyone, let's say, if they're playing it from another country, it would get cached in that country's servers so that they could just play it over there. So similar concept. It's a very easy way to relate all of that. CPU performance optimization, very straightforward. So core performance is on clock. You have multi-cores, and then you have CPU caching and workload optimized. Nowadays, until like maybe 5-8 years ago, commercially or as a consumer grade processor, you would only get normal CPUs, right? GPUs started coming in as part of that also. Now we have, like in GPUs alone, you have certain chips that are useful only for machine learning, right? There are some which are very useful for processing even images specifically, and graphics and AI has become the norm. So you start seeing more optimized processing units as part of. So that's one side of the whole processing side. With memory, it expands. Now from caching, you also get a disk, right? So you have disks where you have long-term storage available, and the CPU will fetch the code and data from memory and then execute the program. So you have this whole pipeline already built in place. It's been happening for years already, and people are pretty used to how it works. And when you use it, it looks something like this, right? So on your desktop or your laptop, when you're actually loading a program, you go to it, and then afterwards you click on a program. It first fetches the binary files and any data files that are needed from a disk, and then afterwards it moves it to a RAM, for example, in this case for memory, and then after that the CPU is actually processing it. So for folks who are in laptops right now, you'll notice sometimes it's super slow. You have to always keep closing apps. It's because your RAM is full, right? So you want to always, as much as possible, keep enough RAM space in this. And the thing is, over the years, this has evolved, right? So I come from a time where this was the norm, right? So you used to have like megabytes, RAM in megabytes. When I started using PCs when I was a kid, I had these big floppy disks, the big 5/4 inch kind of floppy disks. When I finished uni and I gave my project report and my code, it was on one of the smaller floppy disks, 1.44 MB floppy disk, right? That's the amount of memory we used to work with. And over the years, this has just changed, right? So now you have pen drives, and people are still using pen drives. It's pretty normal. You have like every year more GBs added onto it. I still remember my first flash drive I bought, it was 128 MB. I mean, who buys that right now? And you still see a lot of companies and enterprises still using flash drives as a medium of storage. They use it as a medium of even deployment and release. I used to work for a bank before a couple of years ago in the Gulf, and I had as part of a deployment for that bank, I had to give them all the code and all in a flash disk, right, in a bank, and it's supposed to be secure. It was weird because they never actually did a virus scan on the flash disk and just put the code in. They assumed that everything is safe. So yeah, things happen like that also. And when you actually go to enterprise server grade, this is what you see, right? So if you ever have been to a data center, if you haven't, you should. You will see like you have racks and racks of storage arrays, right? Storage farms all sitting over there with disks, which can be hot swappable. Anytime a disk is having a problem, you can just take it out and then put another one, and all the disks are replicating to other disks around in that same space. So you have like storage that is literally evolved over the years to serve what we are doing right now. The kind of every application you're using in terms of in your mobile app or maybe on your desktop or your laptop is always leveraging off of storage and compute of scale like this, right? And ideally, I mean, a lot of folks know about hard disks and SSDs. The fact that hard disks are the older form where it's a disk that is spinning and you have moving parts in it, and it's circular in storage, so you'll always have the spindle that is going around searching for data. Versus an SSD, which is totally electric powered, right? So it's like all you have power going in, and then after storing all the memory internally on the silicon, and then you have that. Because it's faster, there are no moving parts, you're able to access data faster. This is basically how a hard disk would work, right? So you have the spindle, it will fetch the data from a block sector and then read the data and then push it back again, back to the operating system. And we'll see in a bit of how that data moves across layers, right? Because the data which you read from your disk is actually different from the data your application will read at the end. And we'll see that in a bit. So in summary, that's what a server is, right? So hardware resources, you have all these different resources. Some people will use their computer laptop as a server just to host their application and put their website. And that works for a start. But then when you want to start scaling, that's when things start changing. And then that's when you start looking for something much more, right? So that's on basic server hardware. I'll quickly go through what is storage, right? And in a nutshell, storage is just a place to store and retrieve things from. And this is basically what you started with. I mean, much before my time, right? If anyone has heard of IBM punch cards, right? This was used in the early 1900s. And this was the first form of actually writing programs on a punch card. And then you go in and then you put it in a machine and then it would interpret the card and then afterwards it'll spit out an output. And that's changed over the years. This is what you have right now in terms of storages. But the key thing is to understand, why do we need storage, right? What's the purpose of storage in this case? So you're storing data, and in today's world we have what? Photos, we have images, you have videos, you have animations and memes, people who are sending a lot of memes over the wire, right? And then you have Spotify, people are listening to Spotify right now, and other things. And that's, you have all this media, you have all this content that's just sitting over there. And I'm not even talking about all the other things, like databases, like flat files, like unstructured files. And one of the things to understand with storage is that in terms of usage, you have when you actually divide it in by criteria, you will see that there are different types of storage, right? So in terms of usage, you have cache, you have primary storage, secondary storage. In how you access the data, which is what I was alluding to earlier, you have file storage, block storage, and object storage, right? Each one is different from its own case. How you connect to the storage from a networking perspective. So you have a DAS, a SAN, or a NAS network, attached storage. Then you have storage backup, and a lot of companies and enterprises out there, they have backup policies as part of regulation compliance. They want to make sure that all the data that's generated every day is backed up and stored somewhere else, and maybe at a different physical location, so that they want to ensure that, hey, you know what, we can get that data back. You'll see in a moment that with the cloud, a lot of this actually heavy lifting goes away, because you can manage all this through the cloud. Key metrics of storage. This is pretty high level, straightforward, because we could have the whole day and just talk about storage metrics alone. Usually you'll hear about Iops and throughput. So Iops is basically the ability of transaction processing. Throughput is basically average IO block size, and then into the number of Iops. Latency is basically the response time, like we saw earlier, right? About registers and then about a cache. As much as possible, you want to reduce the latency between data being fetched and then returned back. With storage types in terms of usage, this is how it's structured. So you have the more better performance you want, the more expensive it becomes, right? CPU registers are the most expensive. That's why they're smaller in size, and they're used for like super fast processing, so that the CPUs can actually swap data in and out. And primarily, where as a consumer, how we usually look at storage is basically primary memory, main memory, and the secondary memory, right? Hard disks in this case. You also see RAM and ROM as something that keeps coming in as part of this. So I won't go too much into this, because definitely now you're going to start telling me that, hey, you know what, you're covering all our uni syllabus over here. So I'll just go through about caching. It's in general, it's just for temporary storage. Just to keep in mind, caching is basically like ephemeral. The idea is that if you power down a machine, everything just goes away. If you restart the service, everything just goes away. But when it's on and when it's available, it's very fast reads, right? So you have very high reads so that you can read data faster to use. And you use this every day. You're using this in a lot of applications you use every day are using caching behind the scenes. I mean, look at a search engine. Whatever search engine you use will definitely be having some kind of a cache behind the scenes to bring the latest results for you faster, right? You don't actually see a spinning wheel when you're, searching on a search engine. In terms of usage, secondary storage, you have all these different storages. Primarily right now we are in, mostly everyone has an SSD somehow. Floppy, if you have one, it's awesome. You can keep it in the cupboard somewhere and just, show it as vintage classic tech or something. From price perspective, you notice that hard disks are cheaper than an SSD. Performance-wise, an SSD is definitely better. Durability-wise, an SSD is also better. But in a noise perspective, a hard disk is always noisier, right? It'll always have a spinning wheel. I still have an iPod Classic from 2000-ish sometime. Every time I switch it on, it has the spinning disk inside. It'll always keep clicking behind the scenes, and it keeps spinning. So it always reminds me of the old days of hard disks in this case. SSDs are better, but they're always expensive in this case, right? So that's in the medium of the storage itself. But this is where things start getting interesting, right? How do you actually access storage? And you will notice that you are actually doing this right now, right? Even with using the Zoom call, for example, or maybe opening up your browser and things like that. All your files are stored on a disk as blocks, because the disk can only understand blocks and sectors. And then the operating system is able to assemble that together and then create something known as a file, right? When an application reads that file, it reads that file as an object, because it treats it as a special object, right? For example, for the operating system, a JPEG file wouldn't be any different from a PNG file, except for the extension. But when an application like Paint or something else reads it with the metadata, it knows exactly how to render it. So that's when it becomes an object store, right? So the same file assembled across will change this. And you will see this in the cloud, it actually matters a lot. from block, file, and object, the key thing to understand is block storage is raw storage, right? It's hard disks, basically storage arrays and stuff. You have file storage, which is basically where you're storing the files. So if you've ever worked in an office environment, you'll notice that everyone has a central server where they store all the documents, right? Or store all the file. That's basically file storage in a nutshell. Object storage is where it really becomes interesting, because now what happens is that you can actually store all these all your files as an object and then access it through APIs. So you can write programs around it and then just consume the files over an API, which is not the norm, because primarily for accessing files until, let's say, until the last 15 years, you would only be able to access files through an operating system. But now that's changed. You actually don't need an operating system anymore. So that opened up a lot of avenues for how you can manipulate files better in this case. So that's in a nutshell of how storage works. I have a section on network. What I'm going to do is I'm just going to go briefly towards it, and then we'll directly go into the demo, because just being mindful of time also. But it's good to know about network, because everything is connected. Whatever we have right now is fully connected in some form or the other. And you will notice that in terms of all this connection, you'll have something in the middle that will allow you to transfer files across, right? You have like maybe a computer sending a file to a printer. You have like you're downloading a presentation or a video from the cloud into your mobile device. And then you have an email that is being sent from one PC to another PC. And you will interconnect all of these things through maybe a switch or a router, depending on what kind of a network you are on, right? Something needs to always route these things across. And a lot of times in the old days, it used to be all over Ethernet and wireless was expensive, right? In the old days, but that has changed totally. Everyone has a Wi-Fi router, right? Everyone is able to send files wirelessly. You can send even a file across to somebody across the room without even having a mobile connection, for example, just a Bluetooth connective, this one within a couple of meters, you can send it across. And one thing to understand is with network, there's a challenge now, right? So now let's say you have two different disparate systems. How are they supposed to talk to each other? And they may be talking their own thing. They may be talking gibberish, right? So you're basically like, you're not able to understand what it is. So this is where you want to bring in some form of structure, right? You want to say, okay, this data is supposed to be X, this data is supposed to be Y, and you're basically talking about a protocol. So you're telling, okay, when you define a protocol, the data has to follow a certain structure and a format. It has to have a certain way of rendering the data across the network. And this protocol is basically an established set of rules, right? So that determines how data is transmitted between different devices in the same network. Now with network types, this is how, if you actually go into a really nice data center, it's going to look like this, right? Everything is nicely crimped, all the network cables coming out and all that. And this is how it looks like. I don't have another photo of mine. I have one which I usually show in other events, which is like the Swiss cheese of data centers, all of yellow wires all over the place. I used to work in a place like that in my first job. It definitely wasn't as neat as this. You would have wires coming all the way from the roof and all that. But yeah, I mean, it was how it was in those days. So that's from a networking perspective, that's how it was. Now you have different types of networks. You have a LAN, which is basically a local area network. You may have a router or a switch in your home, which would be connecting different devices across. You have a laptop, you have a printer, maybe you have a smart TV, for example, with Ethernet and whatever else. And then you want to now interconnect all of these things together. Now, let's say you're in an office, right? You have multiple floors. You want to connect all this. How would that work? So you're going to have multiple LANs in this place, right? So you have one LAN over here, you have another one over here, and then you have another one over here. And all of that is connected through some kind of a gateway that will connect you back to the internet so that you can publicly access data and then push data in and out and pull data in. So that's basically how you would start looking at a network. I believe some of the slides have got duplicated, so I'll just quickly skip that part. So that works from an office perspective, right? But what if you want a much larger network, right? How would you go global? And that's where you would want to start looking at leveraging off of networks that are already there. This map is basically a picture of the Amazon global network. So it's 100% Amazon controlled resources. And I'll be going a bit into what all of this is all about. There's a slide which I talk about dissecting some of this and the concepts of what a region is and all that stuff. And every one of these lines, they're 100 gig networks, right? So in many cases, even 100 gigs are not enough. We have a lot of parallel lines. We have redundancy between the lines. operates without impact through link cut, and it operates, it has redundant private capacity between all countries except China for other reasons, of course. And that's basically how it is. And we'll jump to the AWS part towards the end. Now, from protocol and a network stack perspective, this is what you're looking at, right? So you'll hear TCP/IP a lot, and this is the stack you're looking at, from a physical layer all the way to the data link between 2 points, to the actual network and the transportation of data. And then you have an application on top that's exchanging the data between each other. This is corollary to what you call as the OSI, the OpenStack interface. And this is basically as part of the application is actually something you can split. So you have two sides of it. You usually see the TCP/IP stack, or you see the OSI stack. I'm sure this is something that's covered already in the syllabuses over there, so I wouldn't talk much about that. I'll skip most of this because a lot of this is very basic in terms of IP addresses. Usually what I do is for folks who are new, especially, I, as much as possible, try to cover even the network side so it's easier. So at a nutshell, this is what networks are going to look like. And you're basically going to be using IP addresses as much as possible, right, throughout this as part of communication. So we'll skip that part, and we'll directly move into databases, because this is where now you're trying to assemble all these things together and make something meaningful, right? Just having CPU power at one end, you have memory and storage at the other end, and then you have networking. What can I do with it? So databases are think of databases as one of the few big applications that have come out over the last years, which are so critical to any kind of application you build, right? For example, any kind of software you're building, whether it's a social media network app, or whether it's a search engine, or whether even it's you're just building something like Instagram, for example, you would want a database to store all this data somewhere. But to understand what a database is, you need to start from the beginning, right? This on the left side, what you see is basically a hieroglyphic tablet from the Sumerian age, I believe. And this is how it was recorded. This is basically recording how many grains are supposed to be given out to people. Keep in mind that at that time they didn't have numbers, so they used to have dots. So they would just punch holes inside. So that's basically grains being transferred from one place to another. Over the years, this has evolved, right? Ledger book is something that came in the medieval times. So this was a time where just during the Renaissance, where people started recording this one, and double entry books started becoming the norm, where you would have credit and then debit, and then you would always match all the data, and then you would draw a red line if you're having less money, or you will draw a black line if you're having more money, right? So this is basically how a ledger started. This ledger concept then started growing. They started using it for something like recording names of people who are entering towns and villages and then exiting towns and villages, which is now kind of what we call as immigration, right? Where you go to the airport and then you stamp on the passport and do that. So databases have been there with us for a long time, but the medium has changed over the years, right? And let's take something which is more frequent for you to understand what a database is, right? So let me ask you this question. How do you actually manage your contacts right now? Right? Right now, everyone has a mobile device, you have emails, and then you have all these contacts that are being stored somewhere on a device. And in the old days, the way we used to do this is that we would meet people together face to face, we would send business cards together, and you would have Rolodexes, for example, and all that stuff. But that's changed now, right? Everything's become more digital. And you want you're storing all this data. Now, the key thing to understand is there's a distinction over here between two terms, right? And a lot of times we also use these terms interchangeably. So on one side, you have just data, which is basically just, like things that are happening. There is like data. Okay, that's a number. It's 20. But what's the 20 for, right? Is it 20 books? Is it 20 cars? Is it 20 ringgit in my pocket? Is it 20 ringgit I have to give you to put in your pocket? So that's data in this case. Information is when you have the context around it, right? So as much as possible, trying to connect data and information. So you need to derive information from data as much as possible. And why it's important in databases, you'll see that in a bit. The key thing is that with data, it's individual facts, right? So you have stats or values, and it's raw and unorganized. And in your case, it could be just a contact detail, for example, or it just could be a school or a college name or a country or region. Okay, we'll just say a country like Malaysia. All right, so are you going to say something about it? No, I'm just saying Malaysia right now. Okay, fair enough. So when it becomes information is when that data is processed. Maybe there's a context. Somebody asked a question, where are you from? Okay, I'm from Malaysia. Or maybe where do you get the best nasi lemak on earth? Well, Malaysia, of course. So so you have more questions like that, right? So who did I talk to yesterday? What languages are trending? And you'll notice that when you start in your current exchange with anyone you do, you have every time you have certain data with you, maybe just lying around, you're not doing anything with it. The moment someone asks you a question, you actually use that question to structure and organize your data so that you can fetch some insights back, right? That's the information that you give back to other people. That's a database. That's all it is, right? So a database, you'll fill all the data in, but you're also going to structure it in a certain way so that you can start answering questions in this case. So some other things to consider as part of this whole data information paradigm is where do you keep the data? How do you know exactly what do you do with the data? How do I access this data? How do I scale it, right? And what analysis can I do with this data? So a gist of databases in this case is that using all of what we have seen right now, it's an organized collection, right? It's an organized collection of logically related data. And a DBMS is something you'll always see used quite widely. A database management system is a software that is designed to store, manage, and provide access to data that's stored in a database. I come from a time where databases were thought as the norm, right? SQL, as we call it. I won't go into SQL and NoSQL, but definitely if that's a topic that all of you are interested in, do reach to the club over here, and they will definitely add that as a future topic. And in my time, SQL was just the norm. Databases were just the norm. Very rigid structures were just the norm. But now things have changed, right? In the last 10 years and all, having data without structure is also possible. You can have databases without structure also, and you can still derive insights from it. So from if you see a database, this is what it will look like, and you have different systems that are connecting to this, right? So you have like multiple maybe servers and computers and even mobile devices that are connecting to a database. If you go deep into a database, you will actually notice there's this concept of tables, which is, if you look at it from, like, if anyone has seen a spreadsheet or an Excel sheet, I mean, this is exactly what it looks like. You would have something known as columns, which would define what the data is in each part of the column. And then you'll start filling all the data in, right? So you'll say, okay, what's an ID? It's 52. What's the name? Okay, Celeste. What's the age? It's 22. And then you fill in more records, as we call it, as part of this. Now, this is basically all the information, all the data that you're having, right? So this is in a table. Now, when does it make sense for you to make this information is when you actually ask a question. So, okay, can I find out what's the the record which has the ID of 53? Right? So that's when I will fetch this specific record. So 53, and then I get that record out, and that's the information I have. Okay. So the question was, what is ID 53? And this is what I got. Now, let's say I want to calculate the sum of all the ages, or an average of all the ages in this case. So I would then do an average on the column. So I'll do a sum, and then afterwards I will do an average and then send that out. Next, I want to find out, okay, I want to find two people who are having favorite animals as owl, right? And this is where I will fetch two records. And then afterwards, I'll just get this record. And maybe another one is I want to find what's the ID for a person called Tom. And that's where then you'll fetch that record out from this case. I'm not showing any SQL queries because definitely this is not a coding session. But definitely SQL is also something we can always look at in the future. So generally, I mean, from that idea of a database, general feature is that it has real-time access. Every time you can fire a query to a database and you'll get data back. There is classification, organization of data. You put data in a certain format or a certain structure, and you're reading it back in a certain form also. Data can always change, right? Depending on the type of database you're using, that data can always keep changing. And you can share data and you cannot share data also. So you can set certain restrictions on that data. And data is independent in a certain way that, okay, if you store data in maybe one table or one database, it should not affect another database or another table, unless you write code which does that, right? Which basically means that your code is buggy and it shouldn't be doing it. So you have pros and cons in a database in terms of how you would want to look at it. You can minimize data duplication. If you're using RDBMSs, one of the things they use in a relational database is you use normalization as a concept. For folks who don't know normalization, it's basically like saying, okay, you try to avoid duplication of data and you keep all data unique across tables, and then you take a unique ID and then do a join across tables, right? Easier to show this in code, but yeah, that's basically how it looks like. Data sharing is easier, standardization is easier, ease of access, and it also saves data storage space because everything is structured and put in a certain way. The cons with the database and a standard traditional database is that you need a DB expert to effectively use it. You need to tune the database performance-wise and other things. It may have potentially a lot of cost because you now have to manage a massive machine, right? And if anyone has gone into a server lab session where they had to set up a massive application, they will get an idea that the machine they have to use for running massive databases is huge, right? You need to ensure that it's always running. So it will be expensive in a hardware perspective. There are complexities with backing up and recovering data, and there's general system complexity. Now, this is something which is in a traditional setup, right? Where the idea is that you have a lot of hardware available, and then you have to manage that hardware to ensure the database is always running. If your databases are all hard disks, you have to ensure that they're always spinning, and if there's a failure in the disk, you have to take backup of it immediately and then push it out. So a lot of that heavy lifting is done as part of your infrastructure, but that changes when the cloud comes in, right? So with all of this, what we have seen in hardware, you'll notice one of the key things is that there's a lot of points of failure across. And when you are setting up an application, when you're building your own application, you're building a website, this is the last thing you want to think about, right? You are looking at the concerns you will have when you're building an application is that you want your application to be stable, it's able to perform well, it can scale well, it is secure, and it's easy to manage, right? So traditionally, if you look at infrastructure as a concept, this is how it looks like. So you have, if you talk of the word infrastructure, it will contain maybe a data center, right? In a data center, you'll have multiple server racks, and each server rack is going to have multiple servers. So if you've ever seen a server, which is basically a rack you can take out, that will have the CPU, and then you'll have the disk and other things, and you'll have another storage array sitting somewhere. So now when you translate this into AWS, it's a bit different, right? With the cloud, what happens is, take that same concept of an infrastructure, right? Now that becomes something known as an AWS region. And a region is basically a geographical location that will have multiple availability zones, as we call it. And each availability zone will have multiple data centers. And each data center will have server racks. And each rack not only has compute, not only has databases or storage, for example, not only has networking, it also has services which are sitting inside that server, right? Which will allow you to do a lot of things like machine learning, for example. So it will have the related hardware, even for the machine learning part. It will have the related hardware for other things that it needs to do. And it will be memory optimized, it will be compute optimized, and even storage optimized, depending on the service you're using. And this is all abstracted from you as a user. When you're using it, you will not know. And you'll see that in a bit when I actually set up a very simple website of how this works. So a data center is basically a collection of computer systems, right? It's a facility. You have servers and storages, and then you have network, all of this interconnection. If you want to do something similar right now, let's say you're setting up an office space and you have one office today in KL, and you want to have another office in let's say in Bangkok, for example, you want to make sure that you're able to set up your infrastructure over here, your servers, your network, your disk, backups, everything. And then you have to also make sure you have a similar setup in Bangkok, right? So ideally what you will do is you will actually have similar setup over there. Maybe you talk to another data center if you don't own a data center, or if you're owning an office, you will try to set up a similar hardware in the office, right? The same server you'll buy and then set it up, but you'll need someone on call over there, right? So this is where the cloud comes in and then changes the game. So with the cloud, what happens is that you take the on-premises concept and now you're making it available for everyone from any point on earth. As long as you have an internet connection, you're able to connect to a cloud service provider, and then you're able to spin up servers, you're able to spin up databases, you're able to spin up storage, you're able to spin up applications, right? All from within your own browser. And this is all enabled by a whole global infrastructure that's put in place by AWS over the years, right? So you right now with AWS, you have 24 geographical regions. You have one local region, which is a concept of having a smaller region within a country. And you have 77 availability zones apart from this. And there are more regions that are coming, right? There are 6 regions and 18 AZs that are coming out across places like Indonesia, Japan, India, Australia, Switzerland, and Spain. And this is a lot of compute, a lot of hardware that we are talking about over here, a lot of services that are being generated. And from a design perspective, this is what it looks like, right? So you have a region, which is basically a physical location in the world. You have multiple availability zones inside that. Each availability zone has multiple data centers inside that, and each data center then has all the services. And this is all built with the whole idea of having high availability, high scalability, and high fault tolerance. So so you can build an application, you can put it in, and then you design your application in such a way that you take advantage of the setup of the hardware, right? So that even if, let's say, there is some failure, because even our CTO for Amazon, Werner Vogels, he says that you always have to design for failure, right? Failure will always happen. But the key thing is that all this hardware infrastructure is in your hands, so that you can design better, right? You can build applications and you can think about your application from a much more usable perspective versus all of these things in this place. So it's 8:45. What I'll do is I'll quickly jump into the demo, and I'll quickly show you what we're talking about over here. So for folks who have not used the AWS console before, when you sign up, and I have a link later on how you can sign up on your own, you will have to use a credit card or a debit card to get in, but it's just for verification, but you get a free tier for 12 months. And when you sign in, you get the console. So this is the landing page for the console. And you are now having a way to...
Sorry, I think we can't see your screen. We can't see your page there. We're still on the slides.
All right, because I shared the...
yeah, I shared the slide. Yeah,
apologies.
no problem. Yeah, it's okay.
Stop the share.
Yeah, sure.
And then I will share it again. Here, just do that. Show the screen.
Yeah, we can see it now. You can see the console. Yeah.
So this is the management console. It's a landing page where you can get access to all the services. And you'll notice if you are someone who was setting up your own infrastructure in different countries, you have to go and call up someone to set up things. Here you can access all your regions in one place, right? So you can just jump into any region you need to, and then spin up servers over there. And you can set this up. And why this helps is because, let's say, for example, you're building an application which needs lower latency for users in right now you're building it for Malaysia and Singapore. So you host it in Singapore, and then later you have users in Seoul, in Korea. You want to host it over there also. You could do the same setup over there and then have the data replicated across if needed from setups. But in our case, we'll keep it very simple. There are a lot of services over here. I mean, every year we keep adding so many things that it's always a chore to keep getting up to date with all of this. But in our case, I'm just going to show a very simple concept over here. So when you're hosting a website, you will basically be looking at getting a server and then some disk space and then a database, for example. In our case, I'll be creating a virtual machine, right? A very simple virtual machine, which allows me to select a location, and I'll keep Singapore as general. And what's the operating system that's being selected? You can select Windows or Unix. And I'm going to select a WordPress website automatically. So this is going to use a blueprint as part of the setup. And what we can do now in this case is that when you set up your PC for the first time, for example, to launch a website, you'll be doing a lot of commands. You'll be doing a lot of maybe setup as part of the whole thing. You can actually create a script and put that as part of the setup. So every time you spin it up, it will run those commands for you. So you don't have to wait until the machine is up and then you go in yourself and then you run it. Then with Lightsail, because it's a virtual machine service which we provide, which sits upon our other compute platform, it has very straightforward pricing, right? In this case, so you get like first month is free in this when you use it, $3.50. So I'll just go with this, and we have a WordPress one website. So I'll just create this, and what this is going to do is it's going to use the image, and then it's going to spin up a machine. And it's going to then create all the networking. So whatever we saw right now, right, from the hardware, it's going to allocate the hardware. It's going to allocate the networking side and everything else, and keep it ready. And it will be a publicly accessible website. So I can paste that link over here, and you should be able to access it. And this is normal. This is something which you've been seeing for quite some time. Anyone who's hosted a website can do this. But where does it become more interesting is that now when I do this in AWS, I can actually start leveraging off of other services. So to give you a taste of what you can do, we have a lot of AI ML services over here in AWS. And this is something which a lot of our customers use. We have different forms in which you can integrate with machine learning services in AWS. One of the services we have is recognition, which is basically computer vision. And we have this as a managed service where you can just consume an API, send an image, and it'll give back a probability of what it is and what it isn't. So based on the demos, if you have an account, you can directly go in and see this. These demos are already available. And you can just choose a sample image in this case. So in my case, I just wanted to set up an image over here. Let me see if I can find it. Yeah. Right. So maybe what I'll do is I'll just use one of these images, or maybe this one. No. Okay, let's do this and see if it's able to get some socks out. Right, my internet is slow, so it's uploading. So this is basically where it's you can send an image immediately, and I think maybe it's because my image is also big. Let me just confirm. I'll try something else. Let me try this. Yeah, this is faster. I think that image was super big. Now we have another service for PPE also. This is what it's doing is it's detecting, okay, it's a general computer vision model that's being used over here. You can check helmet, clothing, and apparel. Now how you use this in your application is pretty straightforward. When you call it with an API, you will actually get something known as a JSON object, a response over here, which gives you all of these bounding boxes, which you can then use to trace, and it also gives you a confidence score, right? So that's basic object detection, and we have a PP detection which does the same thing, but it also checks whether you have a face mask in place, you have gloves in place. It will also detect if someone is not wearing a face mask, which is kind of useful if you want to find people. We have image moderation also, but where it becomes more interesting is now from a use case perspective. I'm not sure how many of you are already in fintech applications over here in Malaysia. There are some applications which require you to do eKYC. Yeah, take a selfie.
Take
exactly,
selfie with your IC.
Yeah. So you take a selfie, and then you have to actually take a selfie with the IC also, send that separately, and it takes like a couple of hours for them to verify and then get back to you. Now, what if you could do that as part of a service, right? So let's say you want to do a face. What you would do is you can use something like face comparison, where you want to check whether the faces match. So in my case, what I'm going to do is I'm going to upload an IC. Right? And I'm going to upload a person who I know who's going to match this IC. And voila, I mean, you have a 99% match that Mr. Bean is actually having an IC card in Malaysia. No comments on how he got it, but yeah, that's basically how it is. And you can also do things like text and image. Like for example, now let's say you're building an app for eKYC, and you want to also extract the IC number, for example. So you could do something like this. So let's take the same image. So with the same APIs, with the same service, you can actually use the same image and then extract all this data out. And you're able to now get the IC number, right? You're able to get the name, and you're able to get all of these things. Now we have other services that are much more niche based on this, where they can actually detect certain things on the text. But this is a good way to just get started, right? So now you can consume this in your app, and then you just start loading it. In my case over here, I just go back to my database, my WordPress site that was spun up, and what I'm going to do is I'm just going to connect to the machine. So I'm just doing an SSH, and in this case, what I need to do is I need to just check if I need to get a password, because we all know that with WordPress, right, you have an admin panel that you want to check. So I'm just fetching that so that I can show you quickly what the WordPress sites will look like. So let me copy this. Let me go to WordPress and get the public IP. This is my public IP over here. So if I go to this public IP, this is my blog over here. And with every WordPress site, there is an admin panel that will be there. So I will just go and set this up, and this logs in. bam, now we have a WordPress site which is up and running. A database is already running within the virtual machine. So now I can access this. I can change the posts if needed. So I can just edit one of these posts over here. I'll just do a quick edit. And let me just update this quickly. Once that's updated, where did it go? The zoom bar is troubling me. It's just on top of the tabs. I'm not able to click this. Okay, let me just do this again then. Right. So there you go. So that's working. So definitely not a dummy. So it actually worked. And that's basically how you get started, right, on the cloud with a very basic website. But this is just the beginning, right? There's a lot of stuff you can actually do on the AWS cloud. So I'll quickly just go back to my concluding slides, and then we'll just go into Q&A directly if there's anything. So let me just go back to what we have over here. Oops. Okay. All right. So with the cloud, the key thing to understand is now you're not worried about infrastructure anymore. You want to start going and building. So how do you get started, right? And we want to make sure that as much as possible, you want to be able to just go hit the ground running. So here's a start. What you can do is there is if you want to like set up an account on how to do this, you can just visit this link over here. I'll just paste it in the chat box for everyone to have a look. Once, of course, I can get chat box from somewhere, which has disappeared again. Just give me a sec. There you go. Here it is. Right. So
yeah, because it's always popping out, so sometimes it's hard to find it.
Yeah, I know, it's just all over the place, right? No worries. Yeah, so you can go to that link and then have a look at how to get started on AWS. Also, what I would suggest is you can also go to our website, AWS Educate. You can search for this. Let me see. And you can sign up with your uni email. I guess you're already part of Educate. If not, what you can do is just sign up. If it doesn't work, just reach out to the tech club and they'll reach out to me, and we can see how you can get all of you on board. The advantage in this is that you get a AWS account which has certain services already in place, which you can start using immediately, right? So that's a good way to start. Then if you want to experiment, right, there's a lot of resources already out there. So how to deploy maybe, let's say, a React app, or you want to build a modern web application, and then maybe you're already hosting something, you want to manage budgets, you want to get credits, and you'll notice that there's a lot of credits being thrown around nowadays, right? So you want to like try to manage all of that together so you can maybe, bankroll your application for free as much as possible. So we have tutorials and all that. I'll just share some of these links over here. Last link which I'm sharing is basically a collection which I'm always updating. So do follow me on that. I'm always updating with really interesting resources because I keep meeting a lot of people and they keep asking me, okay, can you share X, Y, Z? So I usually keep that as a common collection somewhere. So you can start using Tag Packer, pretty useful. And you can follow me on that also. And yeah, so this is a lot of ways to get started on AWS, and we have a lot of content out there. But one of the things is, again, like I mentioned, with the mentor program and all, is that we want to help as much as possible people who are delivering content. They want to help people who want to talk about how to build stuff better on the cloud. You can definitely reach out to me. Here's the QR code again, and I have shared the link before. I can just put it again over here, and you can just give your feedback also. It's very useful for us to understand what's the kind of things you're interested in, what do you want to learn more about. So like I said, this is a very baseline session which we had today, and it's because as much as possible, you want to set the stage so that we can start working on something much more towards next step.
Yeah, really thanks, Chad, for the sharing just now. We get a lot of insights actually about the demo, and so we can see a lot of capabilities of what AWS Cloud can do. So you guys can actually leave your question below here, and we will ask fast, like one by one. Okay, so before that, right, we have some like pre-question we want to ask you is about, like, for example, I want to host a website, or I want to host an app, or let's say a website for this time, a full stack website. So what services like AWS provided did you think like is suitable for thinking for consideration in using to host a full stack website? Yeah.
All right. So with a full stack website, you're basically looking at JavaScript end to end, right? And you want to make sure that you're able to host it. You have a couple of ways you can do that. I come from a time where we used to host Angular applications directly on S3. This was in 2016, right? And this was like nobody was doing this in Malaysia at that time. And it was interesting because what we had done is we had split out our application out of .NET, and we rebuilt it in Angular, and then we kept a REST API and API service. Maybe you use Express, for example, or Node.js, and we hosted that on a virtual machine, EC2, and we kept our app on S3, and it just scaled because the key thing with S3. We didn't go too much into S3, but if you just remember a bit about the storage part, which I mentioned, it's basically an object store, right? You can store objects in that, and then S3 scales. It has 11 lines of durability also. You can use it as a static site host. Now, over the years, we have added a lot of tooling and services to help developers build better on these services, right? So we have these core services in place, and then we have a layer on top. So we have something known as Amplify. Amplify is basically like all the tooling together that allows you to host static sites faster. So you can just use the command line and say, okay, Amplify, and then you deploy, and you get the site. Now you can deploy so you can deploy your website, your static site. You can also then build your application through GraphQL or REST APIs, and behind the scenes, it will create all the Lambda, the code behind the scenes, right? So you can write Node.js code in Lambda and then deploy that. You can host, you can have your data in a NoSQL database, and then you can continue with that. So, I mean, you can never go wrong with just using S3 and Lambda and putting like an API in front. And that just works. The best part in that, which I never touched in this, is that beyond infrastructure, you can also go serverless. So you're never managing any server at all.
Yeah.
Right.
You use a Lambda. Lambda is quite famous for that. Yeah.
Yeah. Lambda is quite famous for that.
For that. Yeah. It's like one of the famous thing about AWS is, especially working with like mobile apps or like websites. Sometimes you don't need a lot of you don't need to use a lot of servers. Just a simple Lambda serverless. Just you charge based on the calls, right? Based on how many calls you call for the Lambda function. What I remember is about that. Yeah, I did have a look of that before. I didn't try it before.
Yeah, I mean, definitely that's a session you can plan for in the future, right? Like a demo of sorts, 1 hour live coding, right? You're sitting and actually building stuff.
Yeah, sure, interesting. And so one more question, right? And also because I found out that you are an AWS associate, you go for the certificate and all kind of things. For example, for students who wish to get hands dirty into AWS, which certificate would you think that is suitable for them for looking for? For example, like cloud practitioner. Yeah, what I know is cloud practitioner. Like the cloud practitioner is like the most beginner one or something like that.
Right. Yeah, good question. So the certs, just to understand, right? A certification is a mechanism for you to show that you know a certain tech or a certain service. With AWS, we have certs that follow different parts of the services, right? From a category perspective. Cloud practitioner is actually the basic. Let me see if I can pull up an image so it's easier for all of you to see this better. Let me pull up one of our AWS certifications, because we have an image that you can usually just show everything together.
Yeah. I didn't have a look on that before.
There you go. Here it is. Let me again share my screen.
I'm not pretty sure why sometimes like in Zoom side you cannot share your entire screen. You need to share like Windows thing.
Yeah, that's interesting. I can't see my. Yeah, this is the one. Right. Cool. Right. So this is basically certification. Like what you mentioned, cloud practitioner is the beginning, but we removed the restriction for doing one cert after the other. You can do any cert from this directly. You don't have to actually start with the cloud practitioner. But what the cloud practitioner helps you to understand is the basics of the cloud, right? What the cloud is, what are the different services that you can use. It's not very technical. So we have a lot of people who are not developers who can also do the cloud practitioner. You could be a business person. You could be even someone who is maybe managing like small shops also, and you can still do a cloud practitioner exam. Where it becomes interesting if you want to become more tech oriented, right, is that you start looking at the solutions architect certification, because the solutions architect certification encompasses a lot of the services at a high level, and it talks about how you stitch these things together and you build a certain solution, right? It's a very good way to get started. Then you start getting into the nitty gritty stuff, right? So you have SysOps and then developer over here, which is more detailed in terms of the certs, and then you have the professional one. And this requires you to know more hands-on. So which is why, I mean, even though this grade is mentioned over here, I've seen different people do it differently. Cloud practitioner is something you can definitely prepare if you just sit and like study about AWS. There's a free training available on our website. You can do this in like 2 to 3 weeks itself, right? And the best part with the certs is the moment you pass one certification, you get a 50% discount for the next one. So you can always keep getting discounts every time you pass. And so that's useful. Definitely.
Yeah, actually have a look on that. I remember it's $99 for $99 for a cloud practitioner.
Yep.
Something, but sometimes you can actually find like discount, like at times sometimes they have like discounts for like registering for the exams. What I actually can see in some groups.
It's possible. There are certain, I believe that is maybe through training centers, for example. Right. So it depends on where you do it, but definitely if you get a discount, use it. Right. I will never stop you. Definitely you should use it. So yeah, I mean that's how you get started with certs. Yeah.
Yeah, and also there's a question here is like what from Austin, he want to ask about what's the most important practical skills and knowledge required as a solution architect.
What's the most important from a software engineer to solution architect? Okay, this is good because this actually is a reflection of the last 16 years. I can sit and talk all day about this, but I'll try to keep it in 1 minute. See, when you start your career as a software engineer, your focus is that you're trying to solve a certain problem, right? So you may have a business problem, or you may have a certain feature or a requirement that you need to fix. What you'll notice is as you start growing in your career, you start seeing that you are not only supposed to be looking at the nitty-gritty, just solving one problem, you have to be looking at a broader perspective, right? So you need to start going outwards and starting to look at, okay, what other different systems am I building things on which will impact it? So in your case, for example, when you start developing, you may be just developing one page and it has to fetch data from a database and you're done with it. But maybe after 2 to 3 years, you're actually building some functionality where other services will be consuming your data and your logic, and then you are impacting it. Anytime your service goes down, those other services also are not going to work, right? So you're starting to look at a holistic point of view in services. So that's how you start transitioning from a software engineer into maybe a senior engineer or a tech lead, for example. Now, where a solutions architect comes into play is you'll reach a point in time where you start seeing that the tools which you use are just tools. Right? The first time you start using a programming language, you have to become good at it. But over the years, you start seeing that the language is just a tool. And your job is not to only just master a tool, you have to understand what problem you're trying to solve. So as a solutions architect, your job day to day will be always about, okay, my company right now is looking at building a massive data store to do data analysis and then get insights for the business. What am I supposed to be building? Should I be building something known as a data lake, for example? Okay, so what is a data lake? Conceptually, it is supposed to have all these data sources in one place, and then I'm supposed to be able to pull data, do ETL and all the stuff. You start designing that whole system. So you're actually building design of a system at a high level, even before deciding what tool you need to use, right? You get in all the processes in place and everything in place, and then you start saying, okay, now what tools can I start using? You will start doing something known as a trade-off, right? And I used to do this in my previous job. Before I became an AWS solutions architect. As an SA in my previous role, I would do trade-off documents. I would sit and say, okay, fine. Instead of using X service, we should be using Y service because of these reasons. But X service also gives us better support. So a running joke we say in the tech world, especially, I mean, you'll get this maybe much later when you actually grow in your career, is that you stop giving the right answers always. I mean, you stop giving answers which you are sure are right, and you'll always keep saying it depends. So every time you ask you a question, I'll say, okay, it depends. And it depends why? It depends on a lot of factors. It depends on what's the problem you're trying to solve. It always goes back to the problem you're trying to solve. And when you become, and it's also about ambiguity, right? When you are a programmer, a software programmer, you are clear about what the problem has to be solved as, right? You know what the answer is supposed to be. So your job is now to try to find the right code to actually solve that problem. But the more you grow in your career, you start seeing that you start actually looking and handling problems that are more ambiguous, where you don't know what the answer is. But you need to figure out what the answer is and then figure out how to execute and do it. So I would say, I mean, I'm 15 years right now in my journey. It's still a journey for me. Maybe come back another 10 years later and then ask me again. Maybe I may have a much more nuanced answer for what else you should be looking at. But definitely this is the journey, I would say. So from a skill perspective and knowledge perspective, if you're very early in your career, master the tools you have right now, right? Become a good programmer in your language which you're using. Learn the fundamentals really well, like whatever I covered right now. That and other things, data structures, for example, and other things. As a programmer, you need to be skillful enough so that any problem that comes to you, you should be able to know how to solve it by code. And then you start looking at broadening that part by building systems, right? So you start designing systems. So you should be able to say, okay, fine, if I want to design, let's say, the next instant messenger like WhatsApp or whatever is currently in the market, or Telegram, how would I build a system like this? How would I design it? So you start looking at it from, components. You start looking at it from blocks. I actually had an architecture diagram I was building for today, but yeah, I didn't have time to complete it. So maybe next time I'll show you, blocks and architecture diagrams and how you actually think in a system perspective. And then you start looking at from a business, then you start building that skill and that muscle for how to make tool decisions, right? Which tool is the best thing to use right now for us, for as a company, as a team, based on budget and all that stuff. So it's a journey. It's not something that's straightforward, but definitely, I mean, like doing some of these certs give you an understanding of, how to look at systems better also. So yeah, long answer for a short question.
Yeah, that's very insightful. Yeah, because so right, yeah, a lot from my experience, we found out that like when you're at different level and you different year, how many years in the industry, your thoughts might be different. Like you probably think of more high level stuff like system design or kind of stuff.
It does. Yep.
Yeah, and so when we are student, we always like, which programming language should I learn? Like this is our main, main concern and main concern, which are different from after working in industry like for several years. Yeah.
I mean, at least you all have a lot of languages to choose from. When I started, I only had Java.
Yeah, but
.NET had just come out, so I just had Java.
Yeah, nowadays university still teach Java. Yeah. Yeah, and also a question from Farah. He want to ask about the security in AWS. How AWS handle if there are any data breaching or DDoS attack?
Okay. Good question on this. So the thing with AWS, and we have like a whole site, and I think one of the links I've shared is also points to security, I believe, in this case. Oh, it's actually in the tag packer. So with AWS, you'll notice that we take security very seriously. Security is job zero at Amazon. And the way we handle this, even from our infrastructure, is different. So we have this concept of a shared responsibility model where when you come and you host your workloads on AWS, we, as part of our SLA, we are telling you that anything that is from the hypervisor, like for example, from the hardware, and then what is the virtual layer on top, from the virtual layer all the way down till the data center, the physical security is handled by AWS, right? And what we are doing in that case is we are ensuring the security is there, we're ensuring the redundancy is there. We are compliant with a lot of the compliance regulations that are already there in different countries, and things like cloud security, right? The ISO certifications and all that. And we have a website with details all of this, because a lot of times people are worried about if they put the data in the cloud. I mean, one of the first worries people used to have, if we put data in the cloud, what will happen if the data disappears, right? For example. And we use the same, our infrastructure is built the same way, and it uses the same tools and the hardware, which is used for also hosting government workloads, for hosting military, and for hosting sensitive workloads, right? For banks, for financial regulations. So we take security super seriously in AWS in this case, right? Now, with the shared responsibility model, what happens is that when you accept that, okay, there's a responsibility model, the moment you host your website. Now, I'll give you an example. In this case, I've hosted a website over here in a public IP. Now, if I go and I share my password on Facebook, anyone can access my website and go into the admin panel and do it. That responsibility of that security is supposed to be mine now, right? Because AWS has given me the infrastructure, they have they put the hardware and they've secured everything else. But if I go around sharing my IP address and my username and my password to everyone, and people can just come in and delete stuff and even, worse, upload things which I don't want to see, then that's on me. So that's a shared responsibility model. And the key thing to understand with AWS, we have different compute abstractions available. So that's where serverless comes in, right? The moment you start going up the stack, the more secure it becomes, right? In terms of management. When you go with serverless, for example, with a Lambda and with S3 and all that stuff, as long as you're not like going around showing your S3, your public bucket, publicly accessible to everyone, it's secure because you are already enabling it yourself. You can enable encryption as part of the setup, right? When you're having data being transferred in and out, you can have transfer of data in S3, for example. You can have security at rest. You can have security at transit, right? You can have SSL certs also as part of the setup. So all of this is already available, and AWS provides this for you. So it's a choice for you on how much of security you want to keep adding on. From a hardware perspective and downwards, AWS is already handling that for you. I hope that answers the question in that for that. And we have a security website which is already there. Just go to the tag packer and you can see that we have a lot of focus on security as such. Me as a solutions architect, what I am also doing with customers is that I go to customers and I always say, hey, you know what, we need to do a review of your setup, right? And we do what is we call as a well-architected review, right? In that, one of the pillars is security. Top priority for us. It has to be secure no matter what. Everything has to be secure, right? And we ensure that, okay, we work with them and then we tell, okay, customers, okay, if you're not rotating your passwords, if you're not rotating other things, you should be doing this. So because we don't have access to the data, nobody does. Only the customer has access to their data internally. And so they use that as a way, and we use that as a mechanism to help customers better. So security is job zero at AWS.
Yeah, it's most importantly, don't set your username and password admin.
Don't do that. Yeah.
admin. Every time when your router is here, admin. When the new router. yeah, it's just a joke. Yeah. And also, right, like for example, when you get started with AWS, like because a lot of people actually concerning about like the cost. How much does it cost? For example, students want to host their project and host their like personal project hosting in AWS. How does it cost? Will you like get overload, or they are like something that can cap your cost or something? I remember there's something like that. Yeah.
So I've put that link about budgets, right? So one of the things you can do is when every time, as a best practice, when you go into in a new account, you should always set up an alert and you should always set up a budget. So what happens is, based on that budget, it'll start alerting you saying that, okay, we do a projection, and then as part of the projection, we'll tell you, okay, you know what, there's a chance that you're going to hit this very soon. So we're going to start sending you emails. We're going to start sending you, notifications and other things, so that you can keep that budget into control, right? Ideally, what you want to do is you want to make sure that you keep a check on what services are being run. There are a couple of ways you can do that also. So by mistake, if you're setting up certain things, maybe you can restrict your region. So like I showed you over here, you have a lot of regions in place in this case, right? Maybe you're sharing this account with other people in your organization, for example. You can restrict all these regions so that nobody by mistake goes in and then spins up something in some region which you don't know about. So there's a lot of other mechanisms you can put. Like I said, this is also a session you can just do for another 2-3 hours just to show that. Now, as a student, what you need to do is focus on putting budgets and alerts in as much as possible, and put an alert so that it comes to your email address and your SMS and all that. And you can just do that over here. And you can just go to your billing dashboard, and you can set up a billing alert. Right now, you're going to see how much the bill is coming for me, but yeah, I'm happy at least AWS is paying this bill for me. So I'm running all of these services. You can see the spend, and this is good because this allows you to start looking at the cloud much more than just going and hosting an application. You start looking at it from a holistic point of view, from a costing perspective. And one of the questions that like Austin asked about being a solutions architect, you also need to keep cost in mind as much as possible. So this allows you to have transparency, right, on how much you're actually spending. So you can go to the cost explorer, and it does. You can do a lot of segmentation on the data. You can go deeper on the data and do it. You can. So in this case, what you can do is you can just set up. We have eligible free tier in this case. You can create and manage your budget in this case over here. So you can just create a cost or a usage budget. So if I just set a budget over here, you can set this every month. I'm supposed to only have maybe like $10, for example. And you can also, at a high level, you can mention, okay, what kind of operation you're doing, and then set up what you're supposed to get after that, right? So let me see if I do this last month. Oh, okay, because I have already hit $24, right? Okay, so I'll go to 50. Wait, you don't want me to keep 1,000, is it?
You can set a limit there. Yeah. Monthly EC2.
Yeah.
EC2 is actually the computing computing services.
Yeah,
right?
this is the computing services, right? So then after that, what you do is you just configure the threshold. Do you want to do it on actual cost or forecasted cost, right? Because you notice Cost Explorer showed me a forecast of how much you think it will get. Put that, you can put an alert, put an email address, and just make sure that you're watching your email always. So what I used to do before I joined AWS was when I used to get an account for free, I will immediately go and set up an alert for $10. If anything crosses $10, I will immediately get an alert. I'll go and shut things down because I'll sometimes forget. Now, that's one side of the whole thing, but you could do something much more from an infrastructure perspective, right? So for example, now when you notice right now, what I did was I am actually going and setting up all this light sail by clicking around in the console and all that. What you want to do instead is you want to use infrastructure as code. So you actually write templates to spin up your infrastructure. And then what happens is that, because the reason why I'm saying that is because now let's say I'm setting up an application that requires networking separately, database separately. I go into different places, create it, and then I forget to turn off something when I'm deleting something. When you use infrastructure as code as a concept, you can create stacks. And then you can say, okay, if I'm setting up a WordPress website, it has a compute, it has a database, and it has maybe a static IP address. All of this is one stack. So if I ever need to go and delete the whole thing, I can just go and click and delete. It'll delete everything at once.
Oh,
right? So,
that's cool.
And you manage that by code. So you can spin it up again later, of course, minus the data because you're fetching it from fresh. So more ideas from that end. But for a student, I would say definitely first thing, do budget alert. I've sent the link already. So do have a look at that. And then afterwards use that. And it's a good way to get started in understanding. AWS Educate is a good way also. That way you don't have to worry too much about the credits. I believe they give some credits initially. I forgot how much.
I think it's less than 100. I think I think that it'll be a long time since I applied for that. So do you guys have any more questions? We can actually ask it. We'll wait for 10 seconds probably. And also by the same time, really thanks Chef for actually accepting the invite for today, and especially it's actually our third talk regarding it's a third talk that we are having to the public. We actually just established this club last year about September time, and also really wish to actually bring AWS knowledge to all of you. And also because I think cloud is actually, if you have a search on the future of IT careers or something, like solution architects or cloud are like top 5 of them. It's really a very important thing. People are less using like old traditional servers, but we are using cloud more as you can scale vertically and also horizontally, a lot of benefits and all kind of things.
The roles, if you ask from a job perspective, I'll say there are 2 roles that are upcoming right now, right? Because solutions architect still requires you to know from a solution perspective. I've seen 2 roles come up in the industry recently. It's called cloud engineer and cloud developer, where you're actually working exclusively on the cloud and you're building cloud native solutions. So a cloud engineer would be someone who's mostly on the infra side, DevOps related other things. And then a cloud developer is someone like, who's building full stack applications on the cloud and managing and leveraging all this, building microservices on the cloud. So this is new jobs. It's an exciting space that's coming up, and for a lot of developers, because it's changed the game for anyone to build applications right now. So definitely it's a career path you would want to start looking at, even from a cloud perspective. I mean, like I said, the certs is a good way to get started.
If really thanks. I think there are no questions from the audience today, and also really thanks Mr. Faz for actually accepting our invite. And you guys can actually follow us from XMUM Tech Lab from Instagram, LinkedIn, and Facebook. We have our last session for X-Pert for this month, which is next Friday 8 p.m. We have a self-driving car company from KL, which they use ASEAN to do self-driving car things. Nice. And also probably next time we would like to invite you for another sharing session again, probably about because I actually heard
I mean totally. I mean, if there's any feedback, people are saying they want more, where we actually go live and do coding and all. I mean, totally awesome. It'd be great to do that.
And also probably we also can talk about DevOps and all kind of things. Because actually last time I attended your DevOps and also like AWS session, which I gained a lot of things. I learned a lot. Especially DevOps.
Nice. It's good. Hopefully we start doing this physically also later in the next couple of months. Let's see.
If we can do it physically, we really like to invite you to our university to actually have it. have it physically. Yeah, but yeah, it really depends on how the pandemic situation goes. Yeah.
Yep, totally.
Yeah.
No worries. Yeah, thanks for having me, everyone.
Really, thank
Appreciate
you, Faz. Wish to see you next time, and also keep in contact with you probably. Yeah.
it. Yep, totally.
And
Yep.
so if we have any
Yeah.
project using AWS or something, we also will contact you.
Oh, totally.
Yeah.
Just reach out to me. Yeah.
Yeah,
Thanks
sure.
for having me, and everyone have a great weekend ahead.
Yeah, thank you, Faz. Thank everyone. Really thank Faz here, and also next Friday at the same time we also have another expert session. You can follow us on all these social media. And next slide, you can go to the next slide. Also, this video will be uploaded to YouTube as well. If you want to rewatch some part or some like insightful part, you can also go to the YouTube to watch it probably tonight. And so it's Facebook as well. Yeah. Thank you everyone. See you guys, and see you guys next Friday. Bye. Thank you, Faz. Thank you.